how is it possible to cut metal with water? Hey, engineering enthusiasts! You've definitely heard that saying, soft water on hard stone, it hits so much that it makes a hole. But have you ever heard of water that can cut through metal? That's right, the same water we drink. And that forms rivers and oceans can cut something extremely tough, like metal. And it's not just any metal. Water jets in blades capable of slicing steel, titanium, or granite with millimeter precision. Behind this process, there's a fascinating combination of physics, innovation, and practical applications that has revolutionized the industry. But first, what is water jet cutting? Basically, water jet cutting, or water jet, is a method that uses a high-pressure stream of water, sometimes mixed with abrasive particles, to erode and cut materials. It is used in industries such as aerospace, automotive, and construction, where precision and versatility are essential. Unlike saws or lasers, it doesn't use excessive heat, preventing deformation and changes in the material's properties. But how can something as simple as H2O accomplish this task? It all starts with the unchanging physical principles that have been explored over decades. The history of water jet cutting dates back to the 1950s, when engineers and researchers were looking for less destructive methods of industrial mining and cleaning. A key name was Norman Franz, a Canadian forestry engineer who, in 1952, patented the first high-pressure water jet machine. His initial goal was to cut wood, but he demonstrated that a concentrated jet could penetrate hard materials. However, the technology only gained momentum in the 1970s when the American company Flow International developed the use of abrasives like garnet or aluminum oxide mixed with water. This innovation made it possible to cut metals, ceramics, and advanced composites, turning the water jet into a viable industrial tool. It was a combination of extreme pressure and abrasive action that made the impossible possible. And how does water cut metal? This is where two proven physical phenomena come in: kinetic energy and erosion. First, the water is pressurized by hydraulic pumps or intensifiers reaching up to 6,000 bar or 600 megapascals, a pressure equivalent to 6,000 times the atmospheric pressure at sea level. Next, this flow is directed through a microscopic orifice, usually made of diamond or sapphire, forming an ultra-fine jet that accelerates to supersonic speeds above 900 meters per second. When it hits the metal, the water transfers its kinetic energy to the surface, creating microfractures. But on its own, pure water only cuts soft materials like foam, rubber, or cardboard. For metals, an abrasive is added to the jet. Tiny particles like aluminum oxide are injected into the stream, colliding with the material at extremely high speed. Each particle acts like a microscopic hammer, chipping away fragments of the metal through controlled erosion. And the result is a clean cut with no heat-affected zones, a crucial contrast to methods like plasma or laser. And what are the essential components of the system? A typical water jet cutter relies on four main parts, all based on precision engineering. The high-pressure pump is the heart of the system, using hydraulic cylinders or intensifiers to compress the water. The abrasive reservoir, when needed, doses and mixes the particles into the flow. The cutting head, where the orifice and mixing tube are located, focuses the jet to a diameter of 0.1 to 1 millimeter. Finally, a computer numerical control table or computer numerical control moves the head with micrometric precision, following digital patterns. The physics behind this is non-negotiable. The extreme pressure ensures that the jet maintains cohesion without dispersing, while the addition of abrasives multiplies the cutting power. Studies, such as those by the Waterjet Technology Association, confirm that metals up to 300 millimeters thick can be cut, as long as the speed and abrasive concentration are properly calibrated. But why is this technology so revolutionary? The answer lies in the unique combination of advantages. First, since there's no heat involved, the material doesn't undergo metallurgical changes, which is crucial for hardened steels or sensitive alloys. Second, the Waterjet is incredibly versatile and cuts everything from aluminum and titanium to glass, plastic, or composites without changing tools. Third, it generates less toxic waste than traditional methods, since the water can be filtered and recycled. Companies like Boeing and SpaceX use this technology for aircraft parts, where precision and material integrity are vital. In medicine, implant manufacturers use water jets to sculpt prosthetics with complex contours. Even artists have adopted the technique to create marble or metal sculptures with details impossible to achieve by hand. And that's not all. Compared to lasers, the Waterjet has no restrictions due to reflectivity or thermal conductivity, cutting thick or highly reflective materials without risks. Today, the technology continues to evolve, driven by innovations in digital control and sustainability. Artificial intelligence systems optimize cutting paths, reducing time and waste. Research focuses on recyclable abrasives and more efficient pumps that consume less energy. Universities like the Waterjet Technology Association are exploring applications in nanotechnology, using microjets for surgical or electronic processes. Still, challenges persist, such as the high initial cost and the wear of components due to abrasion. But the future is promising, where with Industry 4.0, water jets integrated with autonomous robots can revolutionize production lines, making cutting faster, more eco-friendly, and adaptable. From the pioneering experiments of Norman France to today's computer numerical control machines, the secret lies in mastering the physics of pressure, speed, and erosion. Whether it's on an airplane wing or in a smartphone chip, this technique proves that seemingly simple solutions can overcome the toughest materials. If you've made it this far and enjoyed the video, make sure to subscribe if you haven't already, leave your like, turn on the notification bell, and if you find our content interesting, consider becoming a member. To help us keep producing content here on the platform and to be remembered in our videos. So, did you ever imagine that the power of water could be concentrated in a jet thinner than a strand of hair? Have you seen this process up close? Do you own any metal cut by water? Share in the comments. I want to know. Right here on the side, there are two interesting video options that you need to watch to expand your knowledge and explore your curiosity. If you'd like to support us, please like, subscribe, turn on notifications, or become a member. Thanks, engineering lovers. See you in the next video.